Hi everyone, I'm Mohi Faden. Welcome to this series on the solid principles. 5 foundational design principles for writing cleaner, more maintainable, and scalable code. Whether you're new to programming or have years of experience, understanding these principles is essential for building robust and professional software. Let's get started. Alright, let's begin with the Single Responsibility Principle, or SRP. Here's the key idea. A class should have only one reason to change. In simpler terms, this means every class or module in your code should focus only on a single task or responsibility. If a class tries to handle multiple jobs, it becomes harder to maintain, test, and debug. So, why does SRB matter? Let me highlight 3 key reasons. It simplifies code understanding. When a class has just one job, it's easier to figure out what it does. It makes testing easier. A single-purpose class reduces the complexity of testing, since you're only verifying one responsibility at a time. It reduces potential bugs. By isolating responsibilities, you minimize the chances of changing in one area, breaking unrelated parts of your code. These points make SRP a crucial part of writing clean and maintainable code. Now let's bring this concept to life with a real-world example. First, imagine a multifunctional machine that can print, scan, and copy. If this machine breaks down, you lose all 3 functionalities at once. Next, compare that to having separate devices: a printer, a scanner, and a copier. If one device fails, the others continue working, plus it's easier to repair or upgrade a single device without disrupting the others. This is the essence of SRP, keeping responsibilities separate so that your code is easier to manage, debug, and scale. Let's move to an example in code to see how this principle works. Here's an example of what we don't want. A user service class that tries to do too much. It handles user authentication, sends emails, and logs activity. Imagine you need to update the way emails are sent. This change could accidentally affect authentication or logging, because everything is bundled into one class. This design violates SRP because the user service class has multiple responsibilities. Now let's fix this with SRP in mind. First, let's introduce the auth service class. This class handles authentication, ensuring that the responsibility for user authentication is separate from other functionality. Next, we have the email service class. This one focuses solely on sending emails, isolating email-related tasks from authentication and logging. Finally, there's the activity logger class. Its only job is to log activities, keeping the responsibility for logging completely independent. By breaking the original user service into these 3 specialized classes, each now has a single responsibility. If we want to change how emails are sent, we only need to modify email service, leaving the other parts untouched and safe from unexpected changes. This is SRP in action, and it makes our code cleaner, more modular, and far easier to maintain. Let's look at how this works in Python. The structure is similar to the previous example. Here, each class has a single responsibility. This makes the code easier to understand, maintain, and test. Now, here's the Kotlin version. The structure is just as clean as in other languages. Kotlin's syntax makes it easy to see how each class handles a single responsibility. No matter the language, following SRP keeps your code modular and easy to work with. To wrap up SRP, let's go over its key benefits. Easier to maintain. You always know where to look for a specific function. Reduces unintended side effects. Changes in one class are less likely to break other parts of the system. Clearer responsibilities. Each class's role is clear, making the codebase intuitive for you and your team. By following SRP, your code becomes more organized and future-proof. That's it for the single responsibility principle. In the next video, we'll explore the open-closed principle, a powerful way to extend your code without breaking existing functionality. I've added links to the code examples in the description below, so feel free to check them out and try them yourself. If you enjoyed this video, don't forget to like, subscribe, and leave a comment. I'd love to hear your thoughts or questions. See you in the next one.